using the letters of the word birthday. All right, that's the word. Find the probability of selecting two vowels with replacement. All right, so in other words, we're going to draw two letters out of this word birthday, and we want to see what's the probability we select two vowels with replacement. All right, so look at the birthday, and this is where we got to kind of have a little bit of an understanding. So we're going to have a little understanding right off the bat. We're going to count the I and the A as our vowels here. The Y, really, I'm not an English major on this, okay? I think it was a math major. That's why I get to do a math show, right? But I'm really thinking that the Y in this case is probably not a vowel. But you know what? We can look at it as if it were, because sometimes Y and used to be sometimes W. I'm still not sure where that happened, all right? But anyway, birthday, I'm going to go with the A-E-I-O-U version, and we're going to go with the A and the I, which is 2. Now you say, Ernie, what does that mean? It's not the probability, because probability's got to be between 0 and 1. It can be 0, it can be 1, but it's got to be in between there. It cannot be something like a 2 and things like that. However, what we're going to do, we're going to go back to the fact, what is probability? And probability is equal to, I like to call it the number of successes and based on the number of possibilities. See if I can spell that out for you. Possibilities. There we go. So we've got, looks like a little bit of a swinging possibility bridge there or something. Anyway, we have two vowels I'm giving you, A and I, and we've got 8 letters all together in this thing. So basically, we're looking at 2 successes for vowels out of 8 possible letters, all right? That's the whole deal with probability. Now you say, is that all there is? Well, not totally. We can reduce that down to 1/4, make life a little bit easier on us. You say, are we done? Well, the problem said, actually, hang on just a minute. Let me bring it back. Not from the slate, guys. Just take me back just a minute here, all right? I got a little out of whack here. Let's bring it. I've already got it written down here, so to speak. Let's go back here, all right, using the letters of the word birthday, because I just kind of get lost on this. We're looking for the probability of selecting 2 vowels with replacement, all right? So you can tell the end of the year, school year is coming soon, right? We're all getting a little bit loopy here, and it's almost the end of the week, too. Here we go again. There's birthday. Sorry about that. We're going to go back to 2 out of 8, and that's going to give us a 1/4. That's the probability of drawing a vowel, all right? But here's the deal. We're going to make 2 draws, all right? So I'm going to use a tree diagram to show what's going on here, all right? So we pick a vowel, and we pick a non-vowel. We don't pick a vowel, okay? So it's not a vowel. And what's the deal on this? Well, it's 1/4 of a chance to get a vowel, and it's, well, got to be the opposite, right? It's got to be the inverse of this. You say the inverse. It's got to be the complement. That's the good word for it from the probability and statistics point. It's got to be 3/4 there, all right? So the 3/4, because these 2 little branches have to add up to 1, all right? Because that's all the options. It's either a vowel or it's not. Those 2 have to add up to give us 1, because, as I said, they were all our choices, and if we got all our choices all together, they add up to 1, all right? Now, what happened is we replaced. Now you say, Ernie, what's important about that? Well, you know, if you picked the vowel and you didn't replace it, that means you're down to 7 letters and only 1 vowel. If you picked a consonant, a non-vowel, well, you would be down to 7 letters also, but this time you'd still have 2 vowels, all right? But since it's with replacement, we put it back in the pile. We're going to draw again, sort of like you could win a prize twice, all right? If those were your odds of winning a prize, if I draw your name out, think of it that way, all right? These letters representing your name. So if you got a vowel, you win a prize, all right? And again, we're going to let you have another chance. Even if your A or your I was drawn, it goes back in the pile, mixes up, shuffles, whatever, and we're going to go for it. Another vowel or a non-vowel, all right? There we have it. And you know what? If you drew a non-vowel, you've got the same going on here too. You've also got the chance for a second draw. So here's the deal. This is the first draw. This is your second draw. And guess what? I put the vowels back in, or I put the consonants back in. Whatever I drew, I put back in, which brings me back to 8. It still gives me 1/4 chance for vowels. and it gives me 3/4 of chance for non-vowels, all right? Now, we're looking for what's the chance that we get 2 vowels. Boy, 2 vowels with replacement, all right? We've got that marked, but I want to go ahead and finish up the rest of it because some of you may be wondering, well, what are you going to put on the other branches here? Well, it's back to 1/4 and 3/4 because, again, those stay the same. Called independent events. Probabilities did not change, all right? So the independence rule holds here. But what really works for us is we're going to take the 1/4 times the 1/4. And so we're going like, is there a multiplication principle? There is. We could have gone there to begin with, but I kind of like visuals. I like visuals, graphic organizers we call these, to show you. The tree diagram is a great way to show first event, second event, how it actually is working. Because you really had a lot of options here. I could have asked, what's the probability of getting a vowel and not a vowel? I could have gone for what's the chance of 2 non-vowels, all right? And you would have all these probabilities. But by the way, the one we're worried about is vowel to vowel, 1/4 times 1/4, and that gives us 1 chance in 16 or 1/16. That's pretty rare. That's pretty rare. I would not expect to be drawing 2 vowels in a row, except maybe 1 chance out of every 16 times. That's why these fractions are really cool. A lot of you are going, I got a decimal on this, all right? Yeah, you did. 0.25 times 0.25, which would give you, what, 0.0625, which is 625 10,000ths, and goes like, isn't that nice? This really tells me something. 1 chance it could happen out of 16. That's why fractions are really our friends, and they're important a lot of times. So there you go.
For more math help, visit TNLearn.org.